Gambo. Thomas. Ray. Sarkobat. What happened? Yes. Basically, 602 or 602. No, 602. Man, 602. That's the one. Hello, can you hear me, guys?
Yes, sir, Professor.
How are you guys doing?
Tired. The break was too fast.
Yeah, it did. I can't wait for more. All right, guys, welcome back. Remember, after next week, the following week, that's when I will look at the grade book and then see those who have good attendance, and then that time you can request, I can open some assignment for you, provided that your attendance remains good. Now, anyway, taking you to let me show you what you have this week. We'll be finishing the normal distribution this week. So if you look at my announcements, we'll finish reading chapter 6. Then we can start chapter 7 next week. Then have 2 assignments due this week: the classwork 10, which I will put in as soon as we finish, and the homework 6. Now we can begin. Let's see. Let me take you to where our work is. Thumbs coming in. More people are coming in. Okay, good. All right, here we go. So last time we stopped. We are supposed to continue from. Let me check my notes. Okay, we're supposed to continue from standard normal distribution. The standard normal distribution, that's where we're supposed to continue from. The standard normal distribution. Now, the standard normal distribution is a normal distribution with a mean of 1 and a standard deviation of, with a mean of 0 and a standard deviation of 1. So if you remember all the charts we've been drawing, I always put the center line as 0, which represents the mean. So then standard deviation is 1. So what we call it is standard normal distribution, because it has a mean of 0 and a standard deviation of 1. Now, all normally distributed variables can be transformed into the standard normally distributed variable using this formula that you see on the screen. Z equals S minus mean over standard deviation. Where, of course, you know that X is the data value, Z is the standard score, mu is the mean, and the delta is the standard deviation. So let us see the application of this under the applications of the normal distribution. Okay. Excuse me, let me drink some water. Yeah. So let's look at this. Well, it went back. Okay. Say, look at this question here. Excuse me. Say the monthly utility bills in a city is normally distributed with a mean of 0 and the standard deviation. Sorry, the monthly utility bills in a city are normally distributed with a mean of $100 and the standard deviation of $12. A utility bill is randomly selected. Find the probability that the utility bill is less than $70. B, find the probability that the bill is between $90 and $120. C, find the probability that the bill is more than $140. Now, to answer these questions, we first of all have to transform these numbers, 70, 90, 120, and 140 to the standard normally distributed variable using this formula here. Okay? So once we transform it, then we can be able to answer that question. So again, we are told that the mean, let's start from A. A says, find the probability that the utility bill is less than $70. That means we're going to transform $70 to a standard normally distributed variable. Now, we are told that the mean is $100 and that the standard deviation is $12. I had them here, written here, mean 100, standard deviation is 12. So this time around, our X is, for the part A, we have our X is $70. So we need to transform $70. To do that, we use the formula above that I mentioned. I'm going to put it right here. X minus mean divided by standard deviation, which is equal, I'm going to make this in to be 18. It equals to, our S is 70 minus the mean of 100 divided by the standard deviation of 12. So we have to open our calculator. So I'm going to open the calculator so that we can use it. I was wondering what I was forgetting this much. So I'm going to write this thing down, and then we can now calculate it and get our results. Here. So we got we have, okay. All right, I've seen this. Okay, I'm gonna maximize this. So we got this is a calculator. Let me okay. Give me 1 minute. Let me fix this problem. Okay, I know I can fix it. Now, can you see my screen very well? Hello? You can see my
Yes,
screen?
Professor. I'm gonna have to catch up, but yeah, I can see it.
Okay, good. So let's say
I couldn't get off of mute fast enough, but yes, we can see it.
you can see it? Okay, good. Now 70 minus 100 divided by 12.
Can you just say what type of problem you're doing right now?
Yeah, with the applications of normal distribution.
Okay. Did you just start?
Just a few minutes ago.
Okay.
Yeah.
So you haven't done another type of problem already?
I haven't really solved. This is the first problem I'm solving.
Okay, great. Thank you.
So 70 minus 100 divided by 12. So let's go to our calculator and put it in. We got 70 minus 100 divided by 12. negative 2.50. Negative 2.50. So let's go and put it in. Negative 2.50. Now, it is no longer $70. It has now been transformed to negative 2.50. And it is no longer an X. It is now a Z. Okay? It's now a Z. So now, which means that the probability that the utility bill is less than $70 becomes the probability of Z less than $70. So I'm gonna put the symbol. I'll move it right here so I can put the symbol less than $70 instead of less than. So instead of writing $70 now, we're gonna write negative 2.5. So because it has been transformed to negative 2.50 equal. Now, to get this probability, first of all, before we can get it, we need to draw our chart, right? Our chart gonna be in this form. We have, I'll move it all the way down. 0. Then we got negative 2.5, negative 2.5. Then we can place our x-axis. And then the bell curve itself. Okay. All right. Now we're gonna put the center line, which is 0, since it's the standard normal distribution. Okay. All right, all right, all right. Now I say negative 2.50 is gonna be here.
Okay.
So less than $70 now become less than negative 2.5. So you're gonna share this is less than. So you're gonna share that portion of it. Okay. Share it. Then after that, we can be able to answer the question. So I've shared it. Now, next thing is to look at the chart to see what chart looks exactly like what you have here. If you remember, we go to our procedure chart first. Okay, this is a table, but we need the procedure chart. So let's look at the procedure chart first. Okay. So you can see that which of them looks like what I have on the paper. Which of them? So let me show you what I have on the paper again. It's right here. See? Now I'm gonna show you this chart again. Which of this chart looks like what I have on the paper?
The tail.
Yeah, that's number 2, right?
Yeah.
So that's number 2. It's on the tail. And then we can look at the instruction there. It says look up the z value to get the area, subtract the area from 0.5, which means we got with any answer we got from the table, we must subtract it from 0.5 minus. Now let's go to the table and look for the negative 0.2, negative 2.50. Remember, I believe I explained to you guys in the class. If you know how to use the other table, the one they have in homework, fine, you can use it. You get the same answer. But I recommend to use this one so that you don't get confused. The rules for this one is different from the rules for the one on the table. You know, a little bit different, you know. So what I'm doing here, if you apply it to that table, you might fail it. Anyway, now look at this. It says, let's look at, we're looking for negative 2.50. Negative sign is just to tell you, if you're using this table, the negative sign is just to tell you that it's on the left side, that's all. So you'll be looking for 2.50. Not for negative 2.50. 2.50, you get 2.5. 2.5 is right here. You gotta go under 0. You can see the Z. So 2.5 under 0 is this. 0.4938. 0.4938. 0.4938. And that will give you your answer. Let me write it down. 0.5000 minus 0.4938. So let's go and get it from the calculator. The answer on the calculator. So we have our calculator have 0.5, 0.5 minus 0.4938. 0.0062. 0.0062. 0.0062. So that the probability that the utility bill will be less than $70 is 0.0062. Any question on that? Any question? Excellent. Now we can answer part 2. Part B, part B says, find the probability that the utility bill will be between $90 and $120. In this case, we are going to transform two numbers, $90 and $120. So part B, let's go to part B. For part B, excuse me, we still remember the mean is still $100 and the standard deviation is still 2. So I'm going to copy this from here. Mean is still $100 and the standard deviation is still $12. Now in this case, you say between 90 and 120, so that means I have two x's. X1 is 90, x1 equals $90 and x2 equals S2 is equal $120. 120. So we're going to transform all these two numbers to a z. Okay. Then after that we can now answer the question. So let's do the first one. Remember the formula. So for this, there's a slight modification of this formula. So I'm gonna get to the other workbook to get the formula. It's the same formula, but this time I'm gonna put 1 and 2 inside. So let me write these numbers down, and then we can go to that. Workbook and then get the formula in. I got that the mean is 100, standard deviation is 12, x1 is 90, x2 is 120. So we have taking you to the workbook. The formula will now become, inserting this, we're going to have Z1, because that's what the first one will now become Z1. So you have Z1, Z1 equal. Let me make it a little bit bigger so you can see what I'm doing here. Make it 18. Z1. Just making sure you can see this. Yep, you can see it. Z1 equals oh, why is my formula? Okay, Z1 equals okay, x1.
Can you say again why there are two Z's?
Yeah, because there are two numbers. You can see from here. When you look at the question, what is my other question? Okay, I'm gonna find it. When you look at the question itself, give me 1 minute, let me find it. I computer just give me 1 minute. So now look at the question here. Okay, you got it. So it says, find the probability that the bill will be between $90 and $120. That's why you have two numbers, two Z's to do here. So you have Z1 equals x1 minus the mean which is the mean is right here. What is it? Okay, symbol right there, divided by the standard deviation over square root of n. Oh, sorry, divided by standard deviation. Sorry, standard deviation, not standard deviation, which is right there. So with that we can transform this equal. Okay, I'm gonna copy this. So let's go to that workbook and put it right there and get our answer for Z1. So Z1 is right here, equals X1 is 90. Okay, X1 is 90. Green is in. Okay, X1 is 90. So I'm gonna make it to be big enough so you can see the screen properly. So you got make it 18. So 90 minus mean is 100. Okay. 90 minus 100 divided by the standard deviation of 12. Okay, I'm going to write it down. Z1 equals 90 minus 100 divided by 12. So look at Z1. We can now go to our calculator and put it in. So we got 90 minus 100 divided by 12. Negative 0.83. Negative 0.83. Okay. Negative 0.83. Now, it is no longer 90. It is now negative 0.83. And it is no longer X1. It is now Z1. Now, let's do the same thing for X2 by transforming it. So I'm going to take you to that workbook again. The one that have the formulas. So I'm going to change this to Z2 equals X2. So I'm going to copy it and then paste it in the main workbook so we can get our answer. Z2. So this is equals in parentheses, and S2 is 120. So I'm going to make it bigger so you can see it. Okay, 120 minus the mean, and the mean is 100 divided by standard deviation of 12. It's 12. Okay, so we can go to our calculator and get this. Let me write it down first. So Z2 equals to 120 minus 100 over 12. So let's go get it from our calculator. Okay, so you have this. I'm going to change this to 120. 120. In 1.67 rounded. 1.67. So I'm going to go and put it right there. 1.67. 1.67. Now it is no longer 120. It is now 1.67. It is no longer X2. Now it's Z2. Which means that the probability that the utility bill is between $90 and $120 means the probability that the bill is between negative 0.83 to 1.67, which we write in this form between the two, less than Z, less than 1.67 equal. Now, to answer this, we need to draw our charts again. So let us draw our chart to be so that I can answer that question. So I'm gonna put 0 here, 0, and remember we have negative 0.83. Then we have 1.67. Okay. Now let's put the line in. We got here and all this place. And then put it bell curve. Okay. So we need to make some adjustments here. Okay. Okay, let me move this a little bit. Then this one, bring it back a little bit. Oops. All right. Then I can put the center line for them. So this one is right here between this and 1.67. 1.67. So you gotta shed between them. So let me shed it. Okay. Share this. Then, all right. Shedding is more hassle if you are drawing with a computer. But in the classroom on the board, it's easy. On paper, it's easy to shed fast, very fast. All right, let's see. One more. So we have this. Now, let's go to the procedure chart now and look for the chart that look exactly like this. So we go to the procedure table, which is this one. And then procedure chart. So which of them looks like what I have on here on the paper? What do you think? This is what I have on the paper here. So now which of these charts looks like that?
Number 4.
Number 4, right? Yep, number 4. Good. And number 4 says between two z-values on the opposite side, look at the z-value to get the area, add the areas. So you're gonna add the areas. So find them and add them. So taking you back, we get for negative 0.83. We look for it on the table, 0.83, 0.83. Let's see what 0.83 is from the table. 0.8 right here. Go to 3. See? 0.83. 0.2967. 0.2967 plus, let's look at 1.67 on the table. 1.67. 1.67. 1.6 is right here. You gotta go under 7. Say 7 right there. Under 7, then 1.67. 0.4525. Okay. 0.4525. So let's just double checking. 4525. Yeah, 4525. So let's now add them together and then we'll get our answer. I'm gonna write them on paper. 0.2967. 0.4525. So I got on paper on the calculator. We got okay, 0.2967 plus 0.4525 gave me 0.7492. 0.7492. So I'm gonna put it in. Let's go and put our answer in. So our answer to that question is 0.7492. Any question to this one? Any question?
Can I see the problem again?
Yeah, part B is said find the probability that the utility bill is between $90 and $120. Got it?
Okay.
All right, let's solve part C. Part C says find the probability that the utility bill is more than $140. More than $140. So that means we're going to transform $140. Again, our mean and standard deviation are still the same. I'm going to copy it as part C. Excuse me. Part C. The mean they are the same. But this time around, it says more than $140. So $140 is our X. X equals $140. So let's transform it. $140. So I'm gonna move this down a little bit so you can have enough. We have enough room for this. So we have getting the formula for transformation. The formula is this one here. I'm gonna copy this. Okay. So X. So I'm gonna paste it here and put so X minus mean divided by standard deviation. So our X is 140. 140 minus the mean of 100 divided by standard deviation of 12. So let me write this down. 140 minus 100 divided by 12. So taking you to the calculator, we're gonna have 140 minus 100 divided by 12. 3.33. So we got 3.33. 3.33. So it is no longer $140. It's no longer, it is now 3.33. It is no longer an S, it's now a Z, which means that the probability that the utility bill is more than $140 it now becomes the probability that Z is greater than 3.33. 3.33. Okay, equal. Now to answer this, again, we draw our chart. To draw our chart. So I'm gonna make the chart here 0, 3.33. Now I'm gonna put the line here. Then I'm gonna put the bell curve. I'm gonna put the center line. I'm gonna put the line that represents 3.33. Okay, 3.33.
So the shade would be after 3.33.
Yes, because it says more than, that means greater than. So I'm gonna share that plot, share this side. Okay. We got all this. Okay. Two more. I've shared it. One more. Okay. Now, if you look at that, once you have it, next thing is to go to your chart, procedure chart. The procedure chart. So you can see which of them that looks exactly like what I have. Which of them?
Number 2.
Number 2, yep. So you're on the tail, right there. look at the z value to get the area and subtract the area from 0.5. So what we look for the answer from the table. In this answer we got from the table for 3.3, we subtract it from 0.5. So I'm going to write 0.5 minus, and let's look for 3.33 on the table. So I'm going to go there for the table, make sure that you can see this. 3.33. This is 3.3, right? 3.3, but you gotta go under 3. So 3.33. 0, 1, 2, 3. Should be here. Yep, 3 right there. So 0.4996. 0.4996. So let us get this out. 0.5 minus 0.4996. Let me just double check it again. 3.33. Yep, 3.3. 0, 1, 2, 3. See, it's under 3 here. 3.3, 0.4996. Okay, let's go and do the maths. So we got 0.5 minus 0.4996. So you give me this complex, not complex. You give me the answer in scientific form. Now, raised to the power 84 means that you're gonna have 4 zeros before the first significant digit. So this means 0.00004. Okay, 0.00004. So I'm gonna go and put it right there as the probability, the required probability, which is 0.0004. So that the probability will be 0.0004. So this is how it goes. That's how it goes. That's how you apply the normal distribution probability. Now, when you get the chance, you can practice on this one here by yourself and see if you got them right. Let us go to the next thing in line, which is the finding specific values, finding data value using specific probability. Sorry, finding data values giving specific probabilities. For this one, we use this formula, this formula you are seeing on the screen. And for this one, we are looking for the X, which is the data value. The formula goes like this: S equals Z times delta plus mean. Excuse me. Where, as usual, S represents data value, delta represents standard deviation, and mu represent the mean. So let us apply this to one or maybe 2 or 3 questions. It says here, to qualify.
Are they going to give us I'm sorry, Professor, are they going to give us the standard deviation and the mean every time?
For this kind of question, yes, they will you'll be given. Then all you have to do is to get the Z. Once you find the Z and you have the standard deviation and the mean, you just plug it into this formula and you get your X.
Okay.
So if you look at this, which says to qualify for a police academy, candidates must score in the top 10% on a general ability test. Now, when the test has a mean of 200 and a standard deviation of 20, find the lowest possible score to qualify, assume that the test scores are normally distributed. So it said that you're going to score in the top 5%. That means your score will be better than top 5%, means like your score will be better than 90% of the people that do the test. Top 5% is the same as saying 90th percentile. Right? That's what it is. So now let's say you are given the mean. Mean is 200 and the standard deviation is 20. So we're looking for we'll be looking for, let's get our Z first before we can find our X. But before we can find the Z, we need to draw our chart, okay? So I'm going to draw it on this side here. So we have, let me move this Z so I can draw it, the chart. So we're looking for Z. Let me write the Z right here. Z equal. Now, you can see the formula. Now let's start by it's a top 5%. Let's see how this chart will show us the top 5%. Right? Let's see. I'm gonna do it on here. Okay, this is this. Now I'm gonna put okay, I have 0. This is the X we are looking for. We don't know what it is. So I'm going to make sure you're seeing this first. Yep. So I'm going to draw the X axis. Okay, it's a bit longer, but straight. Okay, X axis. Just adjust it a little bit. And okay, now we have the center line there. Okay, well, let's put the line. Okay, all right. Can I move this a little bit backward? Okay, then I'm gonna put the center line. Center line right here. Okay, we have this. This is the cutoff point. We say top 10%, right? Top 10%. I'm gonna write it down. Top 10%. Top 10%. So this is the line that represents the top 10% right here. Oh, excuse me, I have the wrong distance. So let me put the line that represents the top 10%. This one right here. This is the line right there. So that's the top 10%. Okay, that's right. So that means your score have to be this here. This is the cutoff score. As the rule of this now becomes 90%. I mean, the score is greater than 90% of people that do the test. Then top 10% to be right here. So I'm gonna share that section so you can see what I'm talking about. Any score from starting from the top cutoff point off is the score that for qualifying and to represent the top 10%. Okay. I got to put this right there. One more, and then we're done on that. Okay. So it's at the tail. Now, 10%, that means the probability is given already. So let's find our Z. Now, let's find the Z first. Z equals. Now, when we are doing the applications of normal distribution, we say that if it's on the tail, we subtract from 0.5. So you got the 0.5 minus 10%, which is 0.1. That'll give us 0.40. You can verify this with a calculator. Now, let's look at this from the table of normal distribution. We look for Z values that correspond to 4,000. So I'm taking you to the table. 4,000. We got 48084. Okay, we have two. This one is 4015, which is 15 points away. Because 4015 minus, if you ignore the decimal point, 4015 minus 4,000 is 15 points. Now, how about this one? 0.3997. Let's check it. Okay. Let me check it on a calculator. Okay. 4000, ignoring the decimal point, minus 3995, right? This one is 5 points away. But the other one we have, which is this one here, is 15 points away. So this one is closer. Since we did not find 4.400 exactly, we find a number that is closest to it, which is this one here. We follow it to the left. 1.28. So we got 1.28. What's the 1.28? 1.28. With this, we are ready to calculate the lowest possible score to qualify. So the lowest possible score to qualify for this academy is given by this formula. The lowest possible score to qualify is given by this formula. X equals Z times, Z times standard deviation of delta, which is right here. Okay. Plus the mean. This is the mean right there. I copy the symbol. Which is, now remember that I wrote this formula here already before. Z times standard deviation plus mean. So our Z is 1.28 times, our standard deviation is 20. Plus, we got 20, and the mean is 200. So when we put this in the calculator, let's put this in the calculator, we have 1.28 times 20 plus 200. So let's go and put this in the calculator. We got, okay, equals 1.28 times 20 plus 200, which is 225.6. 225.6. Okay. 225.6. So the lowest possible score to qualify for this police academy is 225.6. Any question to this? Yeah, no question. Good, excellent. Let's try another one. It says, because they come in different versions. For a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. So you're looking for two X's. One will represent the lower reading of the blood pressure machine. The other one will be the upper reading. So first of all, let us get the information we are given. Okay, first one, that's mean. I have it somewhere. Let me just put this in mean. Okay, the mean is and then we need the standard deviation. Also need the standard deviation symbol. Okay, right here. So we can see that the mean is given as, said, for the medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. It means systolic blood pressure is 120. 120 is the mean, and the standard deviation is, okay, is 8. So that means because we have to find our Z before we can answer this. So we need to find the Z. We need to draw the chart. And this one, make sure this place, okay, this place is good for us. We got 0, and we got X1, and we got X2, x2. Remember, we need to find the z. We need to find the z1 first and then z2. Since there are two x's, x1 and x2. So let me adjust this and adjust that as well. So I can put the horizontal axis. Okay. Now put the the bell curve. I'm gonna bring this closer. Okay, bring this one closer as well. Okay, I'm gonna put the center line. Oh, excuse me. So let's say it said in. Okay, it said I'm trying to figure out, make sure it's balanced very well. Okay, I'm gonna put the center line. It said the middle 60%. So let me put this thing here. Oh, excuse me. Put the center line right there. So the middle 60%, that means 30% on both sides. Okay. 30% on both sides. Now, next one will be on this side, 30% as well. So they'll be the same size. I'm gonna just a minor adjustment. Okay, so we got 30% here. 30%. Okay, and also 30%. So that they balance the out to 60% because say middle 60%. Say middle 60%. So that means I'm going to shed both sides, say middle 60% of the population based on blood pressure. So let's shed it. Share this. Okay. Share this. Okay. Make sure it doesn't cross the middle 60%. All right. Okay, I'm gonna undo it. Okay, right here. Then 3 more, and I'll have the paper. Have it drawn to finish. 1 more. And 1 more. This represents the middle 60%. Okay. So let's get our Z1. We need this, since that S1 and S, we need Z1 and Z2. So let me write Z2 just for here. Z2 equal. But let's get our Z1 first. Then after that, you can get our Z2. Okay. So Z1 now 30%. So 30% is given already. 0. That means 0.300, right? What it is. That's the middle 30%. So that means from here to X, from this spot to X1. So let's look for this on the table. On the table, 0.3000. 0.3. I see 0.3023, which is 23 points away. I also see 0.255, So let's see how far it is. That 3000, ignore the decimal point, minus 2995. This one is only 5 points away. So since we didn't see 0.300 exactly, we choose the one that is the number that is the value that is closer to it, which is 0.2995. We follow it to the left, give us 0.8. Oh, follow it up 4. So 0.84. We got 0.84. But because it's on the left side, it's gonna be negative 0.84. Since it's on the left side. Now, for Z2, by symmetry, because this side is not this side, so it's the same thing. It's still 0.3 000, which is also, but this time around is on the is on the right side. So it will be positive 0.84. This is by symmetry. Oh, excuse me. By symmetry. Okay. Now we have our Z1 and Z2. So now we can answer the question. Remember that the question says that for the medical study, the researcher wishes to select the people in the middle 60% of the population based on blood pressure. You can see the middle 60% right here. So you're asking it if the means is the means systolic blood pressure is 120 and the standard deviation is 8. Find the upper and lower readings that will qualify people to participate. This is the lower reading, this is the upper reading. So let's find the lower reading first. It's going to be X1 equals Z1, okay, minus, sorry, Z1 times standard deviation of, I'm gonna put it right there, standard deviation, then plus the mean, okay, which is, let me make some adjustments here. Okay, it means Z1 is negative 0.84, negative 0.84 times standard deviation of is 8 times 8 plus the mean. The mean is 120. 120. So let's let me write it down and then we can put it in a calculator. We have Z1, X1 equals negative 0.84 times 8 plus 120. Okay. Let's go and put this in the calculator. We have that is negative 0.84 times 8 plus 120. 113.28 millimeter of mercury, 113.28. Take you there. 113.28. So now that's of course, remember this is in the systolic blood pressure. So you measure the millimeter of mercury. Now for the upper reading, we use the same formula, the same principle, same formula, but now change the numbers. So this is gonna be X2. That'll be Z2. Excuse me, Z2. So control. Okay, time. So that means negative 0.82. Now this one we're gonna remove the negative sign. So you're gonna remove the negative sign because now it is on the right side. So we just calculate it from the calculator. We just go to the calculator and remove the negative sign, and it will give us the result right away. 126.72. 126.72. Okay. 126.72. Let me double check it again, make sure I have it right. Okay. Yeah, 126.72. I have it right. So you can see how the application of this new formula here in this work. Any question before I go to the next one? Any question? Okay. Now, if they ask to find it, okay, let's look at this one. It says SAT scores. SAT scores. Suppose that the SAT scores are normally distributed with a mean of 950 and the standard deviation of 200. Compute the 95th percentile score. Okay, let's see. First of all, you have your solution. Write down the summary statistics that you're given. So you have the mean is given and the standard deviation is also given. You have that the mean equals, okay. I'm gonna make this seem to be bold enough. Make it 18. Okay, the mean is the mean of 950 and the standard deviation of 200. So 950. Then the standard deviation equals 200. And they say find the 95th percentile score. 95th percentile is the score. The 95th percentile score is the score such that 95% of all the scores are below it. That's what they call 95th percentile score. Let me write it down. X is the 95th percentile score. Percentile score. So this is the score. That is the score. Is the score such that 95% of all the scores are below it. Okay, that's what it means. See? And that's what you're looking for, 96%, 95th percentile score. So let us do it. But first of all, let us draw this chart. So I have 0, okay. And I'm going to put the horizontal axis. Then I'm going to put the bell curve. Okay, it's the bell curve. Okay, let's see. I'm gonna shorten this. Okay, I have a 0 here. I think I put the 0 down. Okay, let's see if I can bring this down a little bit. Then I'm gonna bring this down a little bit. So the 0, we're gonna move the 0. 95th percentile score, gonna be X. So then I'm gonna put the center line. The 95th percentile score. Okay, so this is gonna be present. That means 95th percentile score is the top 5% because 95% of the other scores are below it. And this line will present that top 5%. This is represent a 95th percentile score. So I'm going to share that portion to show you the portion that represents 95th percentile score. Okay. All right. Let me share them. Okay. And this one. And that one. Only 2 of them left. Okay. Right. So this one is 90%. Oops, excuse me, sorry, I messed it up. 90%. So 90th percentile score. So this score, and this is the 95th percentile score, right? This line here. Such that 95% below
Yeah,
it.
why does that say 90 and not 95?
Oh, sorry, my mistake. That's my mistake. 95. My mistake.
Okay.
Yeah. Yeah, that somebody's awake, huh? Oh, good, very good. Now, let us find the z then. First of all, let's find the z. Z, when is at the tail, you subtract from 0.5. If you remember, 0.5, okay, minus this 0.05, which is the 95%. So 0.5 minus 0.05, yeah, I can get that from the calculator. 0.5, 0.5000 minus 0.05, oh, sorry, 0.05, 0.45. So that will be 0.45, 0.45. Now we can get it from the table of normal distribution. 0.45 we can get from the table 0.45. I got two numbers. I saw 0.4505, which is 5 points away, 0.4495, which is also 5 points away. So if we have two numbers that are equally close, like this ones, use the bigger one. In that case, the bigger one is 0.45015. Follow it to the left, 1.6. Follow it up, 5. So 1.65. 1.65. Okay, 1.65 is the sorry, 65. 5. Yep. Let me just double check it again. Make sure I'm writing this correctly. So follow it to the left, 1.65. Correct, I'm correct. Now we can find our 95th percentile score. So 95th percentile score is now I'm given by, I got the 95th percentile score is x equals z times standard deviation. I'm gonna put right there. Standard deviation, okay, plus the mean. Okay, our z is 1.65 times standard deviation is given as 200 plus the mean. Mean is given as 950. So let me write this down. Got 1.65 times 200 plus 950. So let's go and get it from the calculator. Okay, got 1.65. Oh, excuse me, I put it in parentheses. Okay, times 200. Okay, plus 950. Okay, 1,280. So that'll be 1,280. 1280. Okay. Now, any question on this? Okay, so now we can now go to the finishing the monomer distribution. We are going to go to the what they call the central limit theorem. Now, what the sum and substance of what the central limit theorem is saying is this: when you take large samples from a population, the sample means, if you get the sample mean of each sample and plot it, it will form a normal distribution. See, that's just what it says, to form a normal Bear curve. So when it does that, that means usually when it does that, that means the sample mean will be equal to the population mean, and the standard deviation will be equal to the standard error of the mean, which is standard deviation over root n. That's what he's saying. That's all. And to solve probabilities that using a central limit theorem, I mean, we can also transform normally distributed variable using central limit theorem if we are given the sample mean and the sample size. So in that case, we use this formula to transform. See, z equals x bar minus mean divided by standard deviation over the square root of n. So where z is the standard score, x bar is sample mean, mu is the population mean, and delta is the population standard deviation, and n is the sample size. So this is similar to the other formula we are using, except that this time around, two things were introduced: the sample mean and the population mean. Sorry, and the sample size. This is x minus mean over standard deviation. So they introduced the sample mean and then they added sample size. So that's the only difference between the two formulas. So let's apply this to solving a question. I'm going to choose one question. Let's do this one. Let's do two of them. Let's do two of them. The first one says, the first one says, Nielsen reported that children between the age of 2 and 5 watched on average 25 hours of TV per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the age of 2 and 5 are randomly selected, A, calculate the standard error of the mean. B, find the probability that the mean of the number of hours they watch TV will be greater than 26.3 hours. So again, the first thing is to write out the summary statistics that you are given. So I'm going to just make sure that you're seeing this clearly. Okay, good. So let's write that down, the summary statistics. I'm going to put the solution. Okay, and I want to use 18. So the mean is given as, let's say that for the mean for the population, we say that Nielsen, AC Nielsen, actually is Nielsen. Yeah. I think Nielsen. So for the population of children of that age, that the mean, the population mean is given as 25 hours, and the standard deviation is given as 3 hours. So make this 18. So part A says find the standard error of the mean. Okay. The formula for let me write this number down. First of all, the mean is 25, standard deviation is 3. So the formula for finding the standard error of the mean is simply means the standard deviation divided by the square root of n. The standard error of the mean is the standard error of the mean is given by this formula. So I'm gonna take care of it, and then let's go to the workbook that allows us to get the formula. Okay, I'll take you there. The standard error of the mean becomes standard error. What we use to represent the standard error is delta delta x bar Okay. X bar equals, excuse me, equals the standard deviation over the square root of n, and our n, in our own case, our n equals let's go to that question and see what our n is. Okay, and it said if 20 children between the age, so let me put it, I'm gonna put n here, equals 20 children, yeah, are selected. So our n is 20 children. And the standard deviation is 3 over the square root of 20. 20. So let's go and get this from the calculator. 3 divided by root 20. We got 3 divided by the square root of 20. 0.671, 0.671, around that, 0.671. 0.671. And that's it. That's the standard error. Part A. The standard error is 0.671, and that answers part A of the question. Okay, 0.671. And then part B says, it says that find the probability that the mean number of hours they watch TV will be greater than 26.3 hours. Now, for this sample of 20, the mean is 23.6 hours. And I find it, so I mean, that's what they said. I mean, that's the sample mean. Now, let us put the variables, all the summary statistics here. Okay. Then let's get the sample mean. Sample mean is 26.3 hours, because it says find the probability that the mean number of hours they watch TV is greater than 26.3 hours. So our sample mean is 26.3 hours. So let me go and multiply X bar 26.3 hours, and sample size is 20. So let's go and get the character, because the character that represents sample mean, it doesn't show here. So let me take you so you can get the character. We have the sample mean, which is given as X bar, okay, equals 26.3 hours. Okay, let me get it from here. Then we can now solve the question. Now we have all the summary statistics here. Okay, everything. So to solve it, we're gonna use this formula that I showed you. Remember the formula, this one here. That's what we're using. So we're gonna use this. So let's go and put it on our formula workbook so that we can get the answer, and then we can come and draw this chart here. So taking this formula here, we have
Can you show the formula one more time?
yeah,
Please.
you know the screen right there. Let me make it bigger. It's right here. You can see, right?
Yes.
Yeah. So
Thank
Yep.
you.
equal, sure. And I put it in X bar, which is 26.3 hours minus the mean of 25 divided by the standard deviation over the square root of n. You have 3 over n. The square root of n means the square root of 20, since our n is 20 children were selected. Okay. Let's see what the result will be. Let me write it down first, and we can go to the calculator and get it. Equals 26.3 minus 25 divided by 3 over, oh, I didn't put square root of 2. I didn't put the square root of 20. Oops. and I'm gonna put it this way. 3 divided by the square root of 20. Square root of 20. Okay, and we can now I got it out of 20. Let's go and put this in the calculator, see what the result will be. So we have 26.3 minus 5 divided by the standard deviation of 3 over the square root of n, which is the square root of 20. Give me 1.94. All right, this is 1.94. 1.94. So let's go and put that in. 1.94. 1.94. So I'm gonna copy this and paste it in our main workbook so that we can continue. Okay. Okay, let me see. Paste it right here. All right. Okay. Now it is no longer 26.3 hours. It is now 1.94. So that the probability of that the mean number of hours they watch TV will be greater than 26.3 hours now becomes the probability of Z greater than 1.94. Greater than 1.94. You see? Greater than 1.94. And to answer that, we need a chart. So we have, let's make our chart here. Here. 0, 1.94. Okay. So now let us insert our bell curve. Okay. From here, go from here. Okay. Right. Now, so I'm gonna put the center line. Then put a line at 1.94. So I'm gonna shade it. I arrange it very well. Okay. And let's shade it. It says greater than 2.26.3, which means greater than 1.94. Let us shade it. Okay, but now you have known how to use the procedure chart, so we will not be going there no more. Just print it out and use it so you can get very used to it. But I already know that when it says the tail, it's subtract from 0.5. So 0.5 minus, but it says exceed greater than 26.3 hours, which is greater than that. So let's go to the table and get our answer for 1.94, 1.9 under 4. 1.9, you go under 4. See 4 right there. Let's see right there. 1.94, 0.4738. Yeah, 0.4738. Okay. 0.4738, which is 0.4738. Let me check it again. 0.4738, 1.9, you're under 4. Yep, 0.4738. I got it. Okay, let's I'll write this down so we can get the answer from the calculator. Yeah. Let me copy this down. We got 0.5 minus 0.4738. Yeah. Let's go and get it. So you have 0.5 and now 0.4738. 0.0262. 0.0262. Right? I mean, I will check it again. Calculator. Yeah, 0.0262. We are correct. 0.0262. Any question on this? Okay, let's do
I
the last.
mean,
You see?
I don't know. I still don't understand what the standard what?
Well, standard error, that means now let me explain to what they mean by that.
Are you gonna do another one?
Yeah, sure.
Are you gonna? Okay.
Let me explain what I mean by the standard error. You look at this. What the central limit theorem is saying. If the sample size is large, let's say that it's a large sample size. Let's say a large sample of some size, let's say 2, or I mean 5 different numbers. Selecting many of it, and then maybe you have a total of 100 numbers, right? But each of them in a sample of 5 in different. Now, if you calculate the mean of that 100 numbers, it will give you an answer, right? Now you calculate the mean of that group of 5s, it will give you the same mean, same answer. If the sample size is large enough. Now, but if you calculate the standard deviation of that, it will be equal to the square root. I mean, if you want to calculate the standard deviation of that group and compare it to the standard deviation of the whole population, it will be equal to and the answer you get will be equal to the standard deviation divided by the square root of n. So that means if you calculate for that sample,
The standard error is the standard deviation divided by the square root of n. What do you need that for? Why is this useful? Like,
you just we use it here as the part of this formula here. You can see right here. Use it here for transforming the z if you have the sample size and the sample mean. You can see right here, this standard deviation over root n. And that's what it is used for. Each time you are given the sample mean and population mean and sample size. So instead of dividing only by the standard deviation that we used to be before, see, when there is no sample size, we divide with only this standard deviation. But when you are given the sample size and the sample mean, you divide with the standard error, which is the standard deviation divided by root square root of n.
oh,
See that?
okay. Okay.
Yeah. So now,
before we didn't have the sample size.
yes, and they give you the sample size and the sample mean. You use that.
Okay.
Yeah.
Thank you.
Let's try another one. Like this one here. It says, there is a large supply. Excuse me. So there's a large supply of the special energy saving light bulb with an average life of 890 hours and the standard deviation of 50 hours. A random sample of 49 light bulbs is drawn. Calculate the standard error of the mean and find the probability that the sample mean will be less than 1,000 hours. Assume that the lights of the light bulb are normally distributed. So let us get the summary statistics we are given. We are told that the mean is there is a large supply of for this light bulb. So that the average light, that is 890 is the mean, and the standard deviation is given as have for 50. See, standard deviation of 50 hours. So I'm gonna make this into be bigger. Yeah. Make it 18. Now a random sample of 49 light bulbs and equals 49 we are choosing. To calculate the standard error of the mean. Okay. Now, if you remember, let's do part A first of all. The standard error of the mean. The standard error of the mean is given by, okay. Now let me write these numbers values down and we can take you to where you can get the standard error. So mean is 890, standard deviation is 50, sample size is 49. So let's see. I will take you to the formula workbook so we can get the formula for this standard error of the mean. So we got standard error. Which is given by delta x bar. Delta x bar, because this is the standard error of the mean. Okay. Equal, have the standard deviation divided by the square root of n. Equals, if you look at what I have in the other workbook, our main workbook, the standard deviation is 50 and n is 49. So you're gonna have 50 by root 49. So that we have the standard error is equals to 50 over square root of 49. Okay. So now we have, let's go and put this in the calculator. Got 50 divided by the square root of 49. 0.7143. I'm sorry, 7.143. 7.143. So let's go copy this. Copy this and then go and put it right there. Yes, 7.143. Yeah. Now we answer part A. Now let us answer part B. Part B says, find the probability that the sample mean will be less than 1,000 hours. Assume that the lives of the light bulb are normally distributed. So that means we need to get the sample mean. Let's look at part B. Part B, okay. And then we're gonna put the values we are given. So we need to get the sample mean. I can't get the character for sample mean here, so I'm gonna take you to that workbook. It said that find the probability that the sample mean will be less than 1,000. So the sample mean is the sample mean for these 49 bulbs is 1,000 hours. So let's go and get it from the character, where you can get the character from the formula workbook. The sample mean equals x bar, okay, equals 1,000 hours. So I'll copy this and paste it into our main workbook. 1,000 hours. Okay. So we're ready to transform this. So we can answer the question. The question says find the probability that the sample mean will be less than 1,000 hours. So let's transform it using the formula for calculating probability based on the central limit theory. So you're gonna be, I'm gonna write this down, 1,000. So now let's go and put it there. So then transforming this, we'll have Z, give me a minute, give me 1 minute. Father. Yeah, come watch you guys. I'm Makuzi here.
Oh, you're not school.
No, I'm Makuzi from home.
Okay.
A remote class.
How long will it take you?
May finish in the next 30 minutes.
Okay,
I can come after later in the night.
This weekend. Huh?
I can come later in the night.
Okay, well.
Or tomorrow. Okay, don't worry, I'll call you, huh?
Okay.
All right. Sorry about that. Sorry about that. That's my brothers, they called. Miss Elliot, what's so funny?
Dwayne. I was watching Dwayne.
Wait.
You speak, what's that, we? Was that we?
Say it again?
You speak we? Was that we?
No, it's Igbo language.
Igbo, okay.
Yeah. Sorry about that, class. I have to, I have no choice. I have to answer them.
Do your thing.
All right, let's see. Now let's complete this. Let's transform this. I'm going to copy this, and then we have right here. So we have let's just transform this now. We got Z equals sample mean, which is this. Okay, minus population mean, which is this one here, divided by the standard deviation of delta over the square root of n. Okay. So we have now the sample mean is X by 1,000. Population mean is 890. The standard deviation is 50 over the square root of n. N is 49. So I'm going to write this down. I have Z equals 1,000 minus 890 divided by standard deviation of 50 over square root of 49. Okay, let's put this on the calculator and we can get our final answer. So we have 1,000 minus 890 divided by the standard deviation of 50 over the square root of 49. Give us 15.40. 15.40 by 15.40. 15.40. So I'm going to copy it. Oh, square root 14. 15.40. Let me double check it again. Make sure I have the correct one. Yeah, 15.40. So I'm going to copy this and come here and paste it. 15.40. Okay. So now it is no longer 1,000 hours. It is now 15.40. And it is no longer X bar. It is now a Z, which means that the probability that the sample mean will be less than 1,000 hours will now becomes the probability of Z. Z less than, because it's still less than, right? So it's going to be less than 15.440. Okay, which is, make it bigger. Make it 18. This will give us see 15.4. Now to do that, we're gonna make the chart. So I'm going to make the chart first of all. We're coming in by this time. Make the chart. I'm gonna have make sure that I've seen all this now. Okay. We click on that, make sure you're seeing it. So let me make this chart. I have 0. Then I'm gonna have 15.4. So I will make it bigger so you can see it clearly. Now I can now put the x-axis. Oops, I picked the wrong thing. I'm gonna pick the x-axis. Okay. So you have this one here. Then put it up. Okay. All right, the same. Okay, we have here. Now, I'm gonna move it a little bit backward. Then, oops, excuse me. Now, the center line, I have to make this adjustment to put the center line. So I'm gonna put the center line now. From here up. Then for 15.4, have right here. Now it says the probability that it will be less than 1,000 hours. So that means P Z less than 15.4. That means from here all the way down. So let's just shed it. Okay. All the way down. Okay. All right. Okay. Now if you look at this, if you remember from the procedure chart, okay, from the procedure chart, may reduce it. Okay, from the procedure chart, you can see that see what we have here. See the diagram we have here. See? And then tell me which one in the procedure chart looks like that. Which one? Yep.
5.
Number 5, right? 5, right? Yeah, that's the 5. That's one right here. Let's see what it says. Say when it is in this form, look at the z value to get the area, add 0.5 to it. Okay. So that means we're gonna have 0.5 plus, let's find the 15.4 from the table of normal distribution. So 15. Remember, we're looking for 15.4, but we cannot find 15.4 here, right? Can we? It's not here. The highest we have here is 3.6. But it says here, for z values greater than or equal to 3.7, use 0.4999. So we're going to use 0.4999 for 15.4. 0.4999 4999. Okay, so we're gonna use, and that will give us the answer we're looking for. If you add it on the calculator, you're gonna get 0.9999. Am I right? You can double check it. So that's the answer for that. So with that, we conclude the normal distribution. Next week, we begin confidence interval. Now, for now, you can start doing the project if you want. You can be doing it little by little. Remember, Excel assignment is part of the project. Let me show you how the project will look like. I don't know if I have it already in.
What Excel assignment? Which one? Where? It's new?
Huh?
We have a new Excel assignment? Let me see.
There's going to be a new one, but that will be next week, after we start the coursework for next week.
Oh, you didn't post it yet?
It will be based on what we'll be doing next week.
Okay, so this week we only have the classwork and the homework, right?
Yeah.
Okay.
Mm-hmm. All right. Any question before we leave?
Have
Can
you
I hear you?
have you
Can you
decided
unmute?
when?
Huh?
Yeah, I'm not. Have you decided when you're going to reopen the homeworks that we can do for credit?
Don't say we, say I, because it's not for everybody.
Okay, well, Phyllis Roberts, you open mine up yet? So I can review mine?
Oh yeah.
Based on my attendance?
Remember I said it's this April. So after next week, you can then send me an email. Then I'll check your I'll see if you qualify. You tell me. So I'll open some of them for you. Sure. So
Professor.
I'm gonna email you too, Professor.
Huh?
Hello?
I'm gonna email you too.
Okay, but email me, no problem.
In a week.
Hello, Professor.
Yes, ma'am.
Hi. I am so sorry. I want to ask, is this class is going to be posted? Are you going to post an announcement? Because
you mean the classwork for tonight?
No, I know the classwork is going to be posted. I'm talking about like the video, the recording.
Oh, the video. Yeah, sure, I will.
Okay, yeah, because I'm so sorry. I really forgot today was Friday. I don't know where my mom was at. So I'm definitely will be honest, I was late today for class a whole lot. Like
no, at least you came. So that's the most important thing.
Yes, okay, yes, sir.
Dwayne, you are saying something before, right?
Yeah, but then I forgot what I was getting ready to say. I forgot. I had a brain freeze.
Yeah. Okay. You know what? Now let me show you what I wanted to show you. See let me show you the project section.
There it is. That's what I was going to ask about, the project.
The project section right here. So you can actually start.
What project? What project? What are we talking about? I never heard about that before.
You're gonna do one project. See?
I remember you said
all the Excel assignment you are doing are part of. See the project. Can you see the screen? All the Excel assignments you'll be doing are part of the project. Now, this is the final project I will put here to next week. But let me give you a glimpse of it. Just give me 1 minute. Let me pull it out.
That must mean you're gonna combine a bunch of stuff.
No. Yeah, of course. Let me show you. Let me show you how it looks. Project. Okay, this is the what is it? Yep, project, the new yep, right here. Okay, see, you can see this, right?
Lord have mercy.
No, it's not something. I make a video on that. It's basically asking you to check like, let's say that you want to study, right? You write the time you started. When you finish studying, you write the time for that day. You record it. That's in minutes. Then next time you want to study, do the same thing until you get 30 different numbers. Now, with that 30 numbers, you can now find the construct a group frequency distribution.
Oh my God!
So you did this already. Hello, why are you opening your mouth like that?
Because first of all, I might not even study 30 more times before the end of the semester.
What do you mean?
Are you serious?
You know what? You know what? I'm going to make a video on this.
Listen.
Huh? As a matter of fact, I did already. I did already.
Are you going to be available to take questions before we submit this assignment?
You mean the project?
The project, yes.
Yeah,
will you be available before we submit it? I don't mean now. I mean like before.
Of course, I can take question, but I may not answer it directly, but I will show you a sample. That's why I want to make a video on it.
Okay.
Hello?
I'm gonna get 30 data points in the next 2 weeks.
I have no idea.
No, I will show. That's why you use a random number table. The video I will show you how, because if you use a random number to select 30 different numbers, let's say that you assume that how long? Let me ask you this, Miss Elliot. When you want to study, right? Like how many hours do you spend when you want to study? Just or minutes?
Probably like 2.
Yeah, that means 120 minutes, right? Right or wrong?
Yes.
So now, in that case, you can use random number table. Let me open the random number table. I don't think that because that will give you the same result you get as if you do the actual recording. So you can read you can use random number table like this one. Let me see. Random. Remember, we did this at the beginning of the semester. How to use
assignment that I need to redo again.
Yeah. See?
Yes.
With this, Miss Elliot says she studies usually 2 hours, right? Which is 120 minutes, right?
Yeah.
You close your eyes and point on this. Let's say I pointed here. I can be going this way, right? That means if I get any number that is bigger than 120 minutes, I will not use it. So see, I got the fact you can take it 3 number at a time, right? 651.
Okay, so I can just pick 30 numbers that are less than 120 from this.
Yeah, yes. 635. I can't use 651. It's too big, right? I can use I can use 722. I can use 805. I can use 302, but I can use 190, right? Write it down. Then you can use 839, 36.
Oh, 190 is still too big.
Oh, sorry, 190 is bigger than 120, right? Sorry, I can't use it. So you keep going like that. 190, 836, 326, 601, 270, until you get. When you get to the end, you continue until you get like now. If I continue here, for example, I can get to the point where I can get 172. I can't use 172, but I can get 300 can't 116. I can use. See, I can use 116. So we use random number to get odd numbers. Now, now if you are studying less than let's say 1 hour 30 minutes. I'm sorry, 1 hour 30 minutes. That means like 90 minutes. Then you're gonna choose two digits until you get the 30 numbers. Then with that 30 numbers, you can now be able to create a frequency table like this. If you like, you can use Excel to do it. Then draw the histogram. Then calculate mean, median. You know, that's so anything you do, when you finish, you paste it here. Or you can do everything in Excel if you like and submit only the Excel file. And so on and so get your quartiles.
We don't have to paste it. We can just submit the Excel file.
Yes, but you have to make sure you put the answers with a title for each of them, so I can click on them and get that.
Right. Okay.
Yep.
So hold on, say that again.
I mean, if you can do all this in Excel, so long as it is well organized. See what are you organize, give titles to each calculations.
Right. Right.
So I can get.
You're gonna do a video on it.
Or you can, yes, I'm gonna do a video on it. Or you can just do you can just do the work in Excel and put the answers here so that you submit the 2 files, this one and the Excel file.
Okay.
So like I said, I'm gonna do a video on it, and then you can just watch the video and follow the direction from there. Okay. So if you want to ask me a question, ask me here. I'm here. Don't send it to chat. I don't answer chat when I'm in classroom. Ask me now. I'm here. Yeah.
I can't answer the question now because I'm not working through the private right now. But I will need help. I mean, I will have questions probably.
Okay, it's private.
So
okay.
should I just email you?
Yeah, email will be good.
Okay.
Mm-hmm.
When is this going to be due?
The project, it will be due before the final exam.
So like 2 weeks?
A week before the final exam, yes.
The final exam in 2 weeks? Lord help me, Lord.
No, who says 2 weeks?
Yeah.
It's not
When is the final?
Final is in May. Hold on.
When in May?
The school haven't given us a date yet.
The first
in
week.
May 14th.
But I thought the graduation was the 14th.
Well, that's when the class ends. Not the day we take the final, but that's the when it will end.
So like last week of April is when this will be due, though.
Huh?
So it's more like the first week of
May.
May.
Probably
The first week of May in the April.
Mm-hmm.
You right, 2 weeks. Yep, because graduation is the 13th.
Are you graduating, Mr. Dwayne?
Yes, sir. And you got to give me at least a C so I can get out of here.
Yeah, you're gonna earn it, Mr. Dwayne. I'll give you the opportunity to earn it.
Congrats.
Congratulations in advance.
Bless your heart. These 2 years, Lord. I should have took. One of my classmates told me to take statistics in the beginning, and I wasn't thinking. I should not have saved this for the end, Lord.
Yeah.
But it's an interesting class, though. Even though it's a challenging, but it's interesting. It's basically it use data.
All I'm gonna say.
And I think you help a lot. I'm sorry, Mr. Dwayne. I think you help a lot, though, Professor.
Oh.
You really do, because this class was confusing. So you help us a lot.
Oh, no
I
problem.
really appreciate the videos. I gotta say, man, I really appreciate being able to go back.
Thank you. I want to do more. Just give me the attendance. That's what I need. I'm willing to, bend the rules so long as you show up.
Bless your heart.
Well, God bless you too. All right, guys. I'm gonna let you guys go, and I'll see you next week. Yeah.
See you next week.
Sure.
Bye.
Bye-bye.
Bye.
All right.
Did you get me, Professor?
Huh?
Did you get me?
Yeah, you say you're gonna email me, right?
Did you get my me for attendance?
Oh, what's your name?
Green.
Yeah, I got you. Green, I got you. Yeah.
Okay, thank you. Have a great
Me
weekend.
too, Professor. Shanika Long.
Yeah, I got you long. Wait, as soon as you get somebody entered, somebody have the iPhone. I don't know that name.
Did you get me, Professor? I know I came really late, but
what's your name?
Selah.
Huh?
Selah. Anna, Selah.
Anna, right? Anna, right?
Yeah.
Yeah, I got you.
Okay.
All right, guys.
Thank you. Enjoy your weekend.
I will try. You too.
All right.
All right, bye.